Hello, everyone. We will in today's lecture, we'll talk about branch and bound method. So what is actually branch and bound method? So branch and bound is one of the technique that used for problem solving. So in our previous lecture, uh, we saw different kind of algorithm like dynamic programming, backtracking, divide and conquer, and different type of algorithms. So it is similar to backtracking since it also uses the state space tree. If you don't know about state space tree, we'll cover it up in our next slide. So it is used for solving optimization problem and minimization problem. So if you're given a maximization problem that also can be solved by branch and bound method, then what we have to do, we have to convert into using the branch and bound technique by simply converting the problem into a maximization problem. So it's possible to solve the minimization problem as well as maximization problem by branch and bound. So what is the term branch and bound mean? So branching is the method of generating subproblems, and bound means ignoring the partial solution that can be better than the current best solution. And it is a search procedure to find the optimal solution. It eliminates those parts of search space which doesn't contain the better solution. And in this method, we usually find the cheapest path in the method. In the method, we also use the BFS, right? So in our next slide, we'll see that why we are telling that a BFS is used in this branch and bound method. So let's jump into the basic idea. So branch, we actually use the word that search space. So actually, what is the search space? So the branch and bound algorithm consists of stepwise enumeration of possible candidate solution by exploring the entire search space. So with this possible solution, we first build a rooted decision tree, and the rooted nodes represent the entire start space. So now you know that what is actually search space means. So search space is something that is represent all the possibilities that can be shown within a rooted tree. So that is actually the entire search space. So here, each child node is a partial solution and part of the solution set before constructing the rooted decision tree. So we set an upper bound for a given problem based on the optimal solution. At each level, we need to make a decision about which node to include in the solution. At each level, we explore the node with the best bound, and we'll ignore the other parts. In this way, we can find the best and optimal solution set. Now, in the crucial to find a good upper and lower bound, in such case, we can find an upper bound using the local optimization method, or by picking any points in search space, or something like cost. We can find out those local optimization. On the other hand, we can also lower bound by convex relaxation or duality. So in general, we want to partition the solution, the setups, into smaller subproblems of solution. Then we construct a rooted decision tree, and finally we choose the best possible subset at each level to find the best possible solution set. So in these tree, you can see that there are root and node 1 and node 2 and node 3, node 4, node 5, and 6 will go to from root to the node 1 because it satisfy our minimum optimization lower bounds. So after that, we'll actually choose the other nodes, and that's why we'll find all the possible and the best solution from bench and bound. So you're ignoring the other parts, and that's why it's called the bound. So when to use the branch and bound? So a branch and bound is a good choice if you're given a problem in a discrete optimization problem. So discrete optimization is a subsection of the optimization where the variables or problem should belong to the discrete set. So for example, if you solve like zero interest programming or network flow problems, you can use the branch and bound method. Also, branch and bound also work efficiently on combinationary optimization problem. For example, given an object function for optimization problem, combinationary optimization is process to find the maximum and minima for objective function, and the domain of the objective function should be discrete and large. So for example, you can solve these kind of problems, and there are some example of these kind of problems like Boolean satisfactorability and integer linear programming, example of combination optimized problem. So these are very in this problem we can use the branch and bound method. So let's understand through an example. For example, a job sequence is given here: job 1, job 2, job 3, and job 4. The first way of representing the job solution, we have to make a state space tree. So the first way of representing the solution of the subset of job could be something like that: S1 equal to job 1 and job 4. In the second way of representing the job sequence will be something like 1 0 0 1. S2 equal to 1 0 0 1. So why first and last element is 1? Because we are considering the job 1 and job 4 solutions. So that's why we're representing in this way, and the second position and third position are 0 because we will not consider this one. But how we can make these space state space tree? So let's go here. For example, you can see that from this is the one is the root node. From the root node, we can expand. We can actually complete the job 1, job 2, and job 3, and job 4. We are expanding it something like in this way because we are actually using the breadth first search. We are not going to the deep. We are actually going to each node, each node. So for considering the root node to the job 1, we'll denote it as 2. So after going to the number 2 node, we can actually complete job 2, job 3, and job 4. And then after completing this node 2, we'll go through breakfast search into node 3, and we'll expand it something like that. We'll expand the node 3 as job 3 and job 4. We'll denote at 9 and 10. After that, we'll go to the 4. We can go to the job 3 to job 4, and we denote it as 11. And in this at last, we'll go to the job 4. After going to job 4, we can expand because this is the last sequence. And after completing this step, we come back to the job 6. And after as we are completed the job 2, we can go to the job 3 and job 4. That is denoted by job 12 and 13. And then we'll go to the job 7, and after that we'll go to the job 9. Why we're not going to the job 4 and job 4? Because we cannot go further, because this is the last sequence of the job that have to be done. So in this way we can explore the state space tree using a stack. This is another method of exploring the state space tree. So for example, from the root node, we can do job 1, job 2, job 3, and job 4. These are denoted as 2, 3, 4, and 5. And all these nodes we will store into a stack, and the last item will stack last, and first item will do first. So but the last item will be pop out. So we'll explore the fifth number node at first, and we will pop out these 5. So after going to the node 5, can we expand it? We cannot expand it, right? So then what we have to do, we will go to the number 4 number node. Can we expand it? Yes, we can expand the job 3 into job 4. That's why we actually expand it into the 6 number node. So that's after expanding those node, we'll stack into the stack. And after that, we'll explore these 6 number node. Can we expand it? Yes. No, we cannot expand it, right? So after that, what we can do, we have to go to the 3 number node, because we pop out the 6 number node. And after going to the 3 number node, So we can actually expand into we can do job 3 and job 4. These are denoted 7 and 8. We will actually add into the stack, and after that we'll go to the last item, that is 8. We'll explore that. Can we expand it? No, we cannot expand it. So after that we'll pop out the 8 number node, and then we'll go to the 7 number node. After going to the 7 number node, can we expand it? Yes, we can expand it, and we'll expand into the 9 number node, right? That's why we're actually adding into the stack. So after that, extra, can we expand it? No, we cannot expand it because job 4 is the last item. So we can pop out it. And after that, we'll explore the 2 number node. After going to the 2 number node, we'll expand is something like job 2, job 3, and job 4. And these are 10, 11, and 12 number node. And we'll stack into add into the stack. This is the one method of for exploring the state space tree. And what is the difference between the previous method and this method? We'll use the queue in our previous example, and in this example we are using the queue method, and in this example we are using the stack. This is the main difference. So another way we can solve the branch and bound problem and explore the state space tree, that is called least cost method. So let us consider the node 1 that have the infinity, that card is in infinity, and we can expand the nodes name into J1, J2, J3, and J4, and each node have a cost, right? So these are the random costs we denote here. So since it is the least cost branch and bound, so we have to explore the node which having the least cost. In this above figure, you can observe that the node with a minimum cost is in node 3. Yes, so you can explore the node 3 having the cost 12. So since the node 3 works on the job 2, so it will be expanded into two other nodes, right? So let's say if we expand the node 3, there are 2 jobs we can do, that is job 3 and job 4. So job 3 is the cost of job 3 is 8, and the cost job 4 is 7. So the node 6 works on job 3, and while the node 7 works on job 4. So in this way we can actually go through our expected answer and optimal solution more fastly rather than the previous one where we used the queue and the stack, because we in those scenario we used we explore all the possible solution, but in here we only consider the least cost, and we actually bound. That's why this algorithm is called in branch and bound. So what is the advantage and disadvantage of these branch and bound algorithm? In branch and bound algorithm, we don't explore all the node of 3. So that's why the time complexity of branch and bound algorithm is less when compared with other algorithm. If the problem is not large, we can do branching, and reasonable amount of time it finds optimal solution for a given problem. So the branch and bound algorithm find a minimum path to reach the optimal solution from given problem. It doesn't repeat nodes while exploring the tree. So what are the disadvantages? So disadvantage is the branch and bound algorithm are time consuming depending on the size of the given problem. The number of nodes in the tree can be too large in the worst case. Also, parallelization is extremely difficult in this branch and bound. So if the problem is small, so we have to in the problem we have to find the optimal solution. We can choose the branch and bound, but if the problem is very large, it's not better to use the branch and bound method. So thank you very much.